Yeah, hello guys. Welcome back to AWS DevOps Lokesh Tech YouTube channel. Today we are talking about services. Okay, if possible we'll discuss about deployments as well. Okay, so let's start. Let's get into topic. So let me share my screen. Yeah, can you see my screen? Are you able to see my screen?
Yes, sir.
Yeah. So what is Kubernetes service? Okay. So for example, uh, you have for example you have IP. Okay, pod, this pod, this is pod and this is IP, pod IP. So yeah, you need to access it, right? So if you want to access this pod, this IP will be there. Okay, so how we have to access? Okay, endpoints by using, by keeping and by keeping services. Okay, group, by using that endpoints we will use the service. Okay, so the idea of service is group a set of pod endpoints into single resource. You can configure various ways to access the grouping. By default you get stable cluster IP. Okay, so address that clients inside the cluster can use to contact pods in the service. Okay, a client sends a request to the stable IP address. Okay, client will send request to the stable IP address. Okay, and the request is routed to pod. Okay, in the service, a service identifies its number of pods with the selector. How it is identifying? A service identifies it member of its member pod with the selector, or pod to be in a member of the service. The pod must have all of labels specified in the selector. Service, okay, and selector. Okay, so by using selector is playing very big role. So you must understand about selectors and labels. Okay, and
Yes, sir.
yeah, so we'll see how services will works. Okay, so if you can see here, you can understand. So what is API version? Pod also we have given same, services we are giving same. Okay, so and see, services we have given metadata. Okay, when you are mentioning about the details of your service, you have to mention metadata. Okay, what is object here? Object is service, right? So this metadata will define about your service and object, right? So metadata, in the metadata you have given the name of the object, which is service. Okay, specification what we have given, selector. Okay, what is the selector? Metrics, departments you have given, engineering and ports. No, not just to, this is sample. Okay, so why Kubernetes service? This is the question actually. People will get mainly this. If you understand, you can understand services. Why Kubernetes? What is the purpose of Kubernetes? Okay, I mean Kubernetes service. Okay, in Kubernetes cluster, each pod has an internal IP address, right? In Kubernetes cluster, if it is a cluster, see, each pod each pod has an internal IP address, right? For every pod. Okay,
Yes.
For every pod has internal IP address, right? For suppose all pods have internal IP address, but the pods are deployment came and go, and their IP address change. Okay, so if the deployment comes and goes, okay, so pod IP address, there are chances to change the pod IP address. Okay, if it doesn't make sense, right? So if for example IP address is getting changed, in the sense service will not work next time, some application you kept, okay, so with you are trying with for example 180, for example 180.160.10.0, for suppose you have access to yesterday with this IP address. So all of a sudden something happened and changed the IP address, okay, means service, so it changed. Okay, if you got 181.160 dot, okay, 10.1 for suppose, so yesterday you have accessed with this, and after that your pod IP has been changed, right? So what does it mean? There is no any sense, it doesn't make any sense, because customer cannot able to access your application, right? Correct.
Yes.
So this is a one of the drawback, so that is the reason we with a service you get stable IP address. With service you will get a stable IP address. For pod, for every pod you are giving one service, okay, in cluster. For some, you are making it as a group and you are giving it as service, okay, you are mentioning the service, and this service you are attaching with the domain, okay, domain. So these are all domains will be in ingress, okay, we'll talk ingress later, okay, just for understanding you just what is all domains, you for suppose you are keeping in ingress, okay. So traffic is comes like this, okay. With service you get a stable IP address, that is a purpose, that is one advantage, you will get stable IP address, okay. That last for life of the service, even as the service, even as the IP address of the member pod change, even if it is pod sometimes, for example replica, for example yesterday we have discussed, right? So pod, something happened, pod changed and it is replaced, you got new pod, all features you will get,
Yes.
but IP with IP address you can't get it back. So if you get a one IP address, you understood, again I'm telling, so there is a some issue happened with your pod 1 for suppose, okay. So it is ephemeral, I told ephemeral in the sense there is no longer, okay, it is it has a chances to die pod itself. So at that time we have a replica set, okay, replica set. What replica set will do, it will create new pod with the same specification, same features, okay. This pod, whatever pod is got created, the same features will get, but IP address will be different, IP address will be different. What then, what will happen if no service? So the customer, okay, application you will get, but customer does not know, right? So this pod got a issue, so again other pod created, okay, so then he can't access, so that is the reason you are keeping all this group in and attaching with the service, okay. So this service is attached with the domain, okay, domain he will access whatever the happen, whatever the things happens, it will be happen inside, okay. So with the service we can able to access the pod, okay, understood.
Yes.
So for load balancing also, we have seen load balancing in AWS, right? Route 53.
AWS. Yes, sir.
Yeah, Route 53. So it is also useful. It is a big advantage. Okay. Uh, For load balancing also we will use service. Okay. So by using service we will also doing load balancer. Okay. So here if you can read the statement, a service also provides load balancing. Clients call a single stable IP address and their requests are balanced across pods that are member of the service. The pods are member of service. Okay, hope you understood. Even if you can't
Yes, sir.
understand while we are doing practice, so while we are doing hands on, then you can understand. Okay, so when you will get, in the sense, I'll do one thing. So I will prepare a small project for you. Okay, so including all the
Yes, sir.
services, including pod, whatever we have discussed, replica set, okay, and services, deployments. Okay, so by doing all this, so we'll create one small project. Okay, I will prepare for that. Okay, I will make it ready.
Yes,
So
sir.
then we will do that. So then you can understand, okay, where services are acting, where secrets are acting, and where deployments are working properly, why deployments are working, uh, so where labels are working, so how selectors are working, so what is the difference between version like API versions. So there we have using one sometimes v1, we are using sometimes app slash v1, so something like this, right? So once if you done small a project, so you can understand, I hope you can understand so clearly. Okay, so what are the services we have, what are the
Yes.
type of services we have currently? So we'll see. So cluster IP, these are all services. Okay, cluster IP service, NodePort, load balancer, load balancer, external and headless. So these are all service type of services we have. It is available, right? So what is cluster IP? This is a cluster. Cluster is containing pods, okay, and services domains.
Pods.
So this is a one cluster. Okay, internal clients sends a request to stable internal IP address. Okay, so if you using this is cluster, internal clients send request to stable internal IP address. Okay, this is for internal. Okay, what is node port? Clients send request to IP address of a node on one or more node port. Okay, values that are specified by service. Okay, you, so there is a node. Okay, if this node, for example, clients send request to IP address of a node on the on one or more nodes node port, values that are specified by service. You understood this point?
Yes, sir.
So load balancer, clients sends request to IP address of a network, load balancer. Okay, external name, internal clients use DNS name of a service as an alias of external DNS name. You know this, right?
Yes, sir.
Alias, we have discussed about aliases.
Yes, yes, sir. And Linux.
Yeah. So this headless, no, I did not use this, but still, we'll see what is this. So you can use headless service when you want a pod grouping, but don't need a stable IP address. The node port type is an extension of cluster IP type. So service of the type NodePort has a cluster IP address. The load balance type is extension of NodePort type. So service of type load balancer has cluster IP address and one or more NodePort values. If you can understand, please let me know.
Yes, sir. Understood.
Okay. So next. So first we'll see cluster IP address. What is cluster IP? So cluster IP service are used for communication between pods. Okay. Cluster IPs, cluster IP service are used for communication between pods. Okay. So this is for internal client. Okay. So the service gets exposed on a static IP unique within the cluster. When you make a request to the IP, the service takes care of redirecting traffic to one of the pods it's associated with, and if there is more than one pod, the service will automatically balance the traffic, so no single pod gets bogged down and too many requests. Okay. So note, cluster IP services are member of pod to pod communication only. Okay. They aren't accessible from outside of the cluster. Okay. So outside of the cluster we can't access. It is for only internal client, internal side, internal communication purpose. Internal client in the sense not person. Okay, it is for internal purpose. If you can see this this where we have replica set. Yeah, this one, if you see, this is cluster IP. Okay. So in the image above, the green bar titled this. Okay. Backend represents a cluster IP service. One cluster IP service created for backend side, and it is connected with the pod. Okay. And it is connected with the front end and backend. Front end service and backend services. Okay. It sits in front of the pods labeled backend and redirect incoming traffic to one of them. Here are example. This is the way how we have to do. We have to use API version v1, kind service, metadata, we have given a name of service, spec, type, cluster IP, selector, run app nginx, ports we have given, right? Next. Next one is NodePort service. So we will use these services, okay, where we will use to access the applications. Okay. See
Yes, sir.
where NodePort services useful. The NodePort service is useful when you need to expose your application external clients. Okay. External means we, anybody other outside people can able to access by using NodePort service. Understood? So in what is
Yes, sir.
cluster IP? Cluster IP, it is for internal. This is for internal purpose.
Yes, sir.
Cluster IP can
Internal purpose.
communicate pods each other internally. This is for external client. This is for internal. Okay. This means traffic, all traffic that is coming from outside of the network or outside of the cluster. Okay. Whatever traffic is getting, that is getting from outside. When you create a NodePort service, Kubernetes opens a port. This is and this is. I told you, right? While we are creating, I have given a port 30,000. In inbound rules, we have mentioned this before
Yes, sir.
installing. Kubernetes. Before
Yeah.
installing Kubernetes, I have opened
Yes, sir.
this IP address. Do you remember? This is the IP where,
Yes, sir.
for suppose if somebody asks, uh, what is the IP for NodePort? What is IP for NodePort? Means that is for range in between 30,000 to 32,767. This is for NodePort. Okay. So same port is used across them. All traffic incoming to the worker node IP address and that specified port redirect to pod linked with the service. Okay, that's okay, not a big deal, extra useless, that is all. Okay, so this is, I don't think that you can able to see this. This is a very small one. That's fine, we have a lot of examples. Okay, API version, kind, metadata name you have given, specifications to type, port to, target port to, what is target port? Okay, 80. Okay, and node port so and so we have given. Okay, so these are all we have to give. And so if you can see this structure, you can understand it is in cluster. Okay, this is outside, this is for outside traffic. Okay, maybe you or maybe me are hitting continuously. First it will, the traffic goes to virtual machines. Okay, and here, from here it will access by using port, whatever port, I think it is 30,000. Okay, so next this traffic will distribute and it will goes to service first. What service will do is, service will send this traffic to pods, respected pods. Why? It is for load balancing, right? For example, I will tell you, for example, I have only one pod. Okay, I have only one pod. For example, this is my pod. Traffic, getting traffic from different users, 100 users for suppose. This traffic will go to the service. What service will do? It will check how many pods available. Only one pod. So all traffic will be on, it will depend on only one pod. So pod will be stop working or it will late response, then application will goes down. Okay, so instead of that, if you have a three or more pods in a cluster, okay, so in that time, for example, if you have a traffic, huge traffic, so what service will do is, service will distribute the traffic like this. Understood? Okay, service will
Yes,
distribute
sir.
the service will send the traffic to the pods. So it is kind of load balancer. Okay, you understood? So this is what will happen.
Yes.
It's okay. Right, next. Right, okay, so you understood, right?
Yes, sir.
Okay, just see this. API version v1, kind service, metadata, name, nginx node port. This is the name of service. Specifications what we are giving, type, what type it is, node port. Okay, selector, run, what is app nginx service. So this is name, we are keeping name for selector.
Yes, sir.
Ports what we are mentioning, node port so and so port and 80 for target port. Okay, right. So next, so load balancer service. Load balancer is also service, right? So first
Yes,
external
sir.
IP you will get, sorry, external client will hit the request. Okay, so
Request, yes, sir.
then yeah, external load balancer, what it will do is it will distribute the traffic to nodes. In nodes, worker node, for example, worker node and worker node 2 is there. In worker node, what are the pods are there? Maybe if it has some kind of pods, it will distribute the pods, distribution in between worker nodes, in between nodes. Okay, not in between pods. Okay, so load balancer service is another way you can expose your application to external clients. It is another way, right? Because we have seen other way by using NodePort. By using NodePort also, we can able to access the application by using external client. Okay, so by using load balancer also we can able to access the application. Okay, means external client will can able to he can able to access the application. Okay, so the load balancer service detects the cloud computing platform. What is this? Yeah, all this useless stuff. Okay, let me try to read. The load balancer service detects the cloud computing platform on which the cluster is running and create a appropriate load balancer in the cloud provider infrastructure. The load balancer will have its own unique public IP address. Example, it's okay, not much. Okay, so next. So like this load balancer, you have a load balancer here, and traffic is hitting, it will goes to service again, same, right? Same like NodePort, correct?
Yes, sir.
Right. Next, next. Okay, you can see the example. API version 1 kind service. Okay, metadata name. So you can observe here no load balancer here. Here mentioning. I feel little doubt. Just give me 1 second. Mm, excuse me. Yeah, you see this? Yes, service only we are using. Correct.
Yes, sir.
So same service. Yeah. API version 1 service metadata. Here we are giving Nginx load balancer. Okay, so specifications, type load balancer, selector, API, some app and Nginx ports we are giving 80, right? So these are all. Next, external name service. External name service in Kubernetes, it is useful when you have a service that is running outside your Kubernetes cluster, such as database, and you want to access it from within your cluster. Okay, so this simply it will define external namespace service in Kubernetes useful when you have a service that is running outside of Kubernetes cluster. okay, like a database, something such as database, and you want to access it from within your cluster. It is external outside, but if you want to access it within a cluster, then you can use external name. Okay, so for example, let's say you have you have an app in the pod. You have an app in, this is pod, this is a app. Okay, you have a app in pod that need to access external database running at domain name so and so, this db. Okay, okay, okay. So yeah, external database running at the domain name so and so, this db hyphen pod example.com. For this database you can create external, this external name service named say db hyphen pod. Then when we that's okay man, same whatever we are, it's, you can keep here. See this, don't look at, don't look it here. App version v1 we have given, kind service, metadata, the service name is db pod. Okay, why we are using the external pod? By using this outside of the, okay, outside of the running outside of the applications like database. Okay, by using this we can able to access. You understood?
Yes, sir.
So note that external service does not have any selector. Okay, yeah, you can understand, this is no selector. Fine. Okay, defining a service with a cluster, sorry, defining a service with a selector. So API version v1, kind service, metadata name, this specifications, selector, and app web server. Why, what is this here, all in same? Maybe it is wrong, indentation is wrong, right?
Yes, sir.
Yeah, it's okay, no problem. But what are the things, fields given? API version, kind, metadata, and specifications, selector, selector name, what is the selector name, this, and ports, so and so ports. Okay, Kubernetes will automatically assign an IP address for the cluster, small thing. So you see this, Kubernetes will automatically assign IP address, okay, which will then be used by service proxies to route the traffic. The controller of the selector will consistently monitor the pods matching a defined label. See that again, label by using label, 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 okay, and selectors. By using this, it will monitor, okay, consistently monitor pods by using labels. Okay, this is the advantage of label also. For this also, this is also another advantage. See, port name can only numerical character and dash symbols, should start and end with alphanumerical. Okay, right? So these are all okay. Let's examples given, endpoint all we have seen. Let's go. Okay, so let us take this example. Okay, yeah, fine. VA, so load balancer. No, I want, we'll go one by one, right? So let's go with cluster IP. See, individually, yeah, we are going to use this now. So cluster IP service, cluster IP, CIP. Please remember YML. Are you feeling boring today? Okay, so I copied.
No, sir.
So yes, okay. So let me apply kubectl, kubectl apply -f CIP cluster created, right?
Yes, sir.
kubectl get all. Where is that now? What is the name of that backend service,
Backend service.
right? Where is backend service here?
Yes, sir.
Where is backend service?
Sir, we have created like services of some kind, but we are
Correct, not,
searching for
it
pod.
is pod, right? Okay, kubectl, yeah, SVC. Let's try with SVC. Get SVC, yeah, backend service, what, right? We can use
Yes, sir.
SVC and also service. So I habituated with kubectl get pods. See, can you see here? Kubectl get service and also get
Yes,
SVC.
sir.
So kubectl get SVC, SVC -o wide. Okay, so it got created, right? So next,
Yes, sir.
describe kubectl, describe backend service. Let's see this. What are the error? Why error?
Sir, describe SVC, which pod or service we have to mention. For
Describe
pod, we were mentioning, I think.
svc, correct, right? Name. So, so namespace given, labels not mentioned, right? Selectors, yes, app backend. Okay, type cluster IP, family single stack. Okay, so IP, so this is IP, port 80, it is unset, target port 8080. Okay, session
Yes, sir.
affinity, that's fine. Okay, give me 1 second. I have services. Okay, so let's go and create other one, NodePort service. Okay, so yes, vi NodePort hyphen service dot yml, right? Save. kubectl apply hyphen np, created. kubectl get svc hyphen o, sorry, wide. Some other services just 15 seconds back created, app web. Okay, so what is that? Web service, right? Which means NodePort
Yes, sir.
service created. Okay, so by using this we can access port. Targeted port is 8080, node port is this much. Okay, so node, this is node port, this is targeted port. So by using this you can able to access your application, web services application, right? So we did not mention any application,
Yes, sir.
just for this is for understanding. You understood? Yeah, next to load balancer service. Okay, vi, okay, dot yml, kubectl apply hyphen f load balancer. Okay, kubectl get svc, right? Right, it is getting clearly, right? Selectors separately, edge, ports, external IP,
Yes,
cluster
sir.
IP. It is providing name, type, cluster IP. Okay, external IP. So this external IP is important. By using this external IP we can able to access. Okay, ports, whatever port we have mentioned, the same. Okay, this is node port, this is target port, right? So and this is selector.
Yes, sir.
Yeah, next external name service. Initially it bit difficult to understand, but if you do continuous practice you can understand. kubectl apply -f external s kubectl get svc -o void, right? 11 seconds. External db, right? So here you can, if you can understand, no selector we are not mentioning, okay, no target port, okay, and cluster ip. So if you go here, so no selectors, right? That's why no selector. Port also not mentioning port, that's why no port, okay. Cluster ip not there, okay. Remaining it is appeared, okay. So this is all about the services. So these services depends upon requirement, you can use this, okay. So which means you have a services available, in the sense it's not mandatory to use, depends upon your requirement. If you know the concepts, if you know where you want to use all these things, so whenever requirement comes, so you can use these services according to your requirement. You understood? It doesn't mean that you
Yes,
have
sir.
all the services, it doesn't mean that you have to use all these services into your applications, okay. So you can you have
Yes.
these kind of options, services, so these services you can use, right? So this is all about services. So where is that freshers? Okay, I'll keep here only. You can take it, right? This,
Yes, sir.
but unable to copy all. I will copy in notepad. Wait, give me 1 second. This is official document, so if you have enough time, just go and read this, you clearly understand. So what is a service, what is the purpose of it? So in Kubernetes service is a method exposing network application that is running as one or more pods in your cluster. So there are one small examples are there, okay. So port definition, okay. So this official documents also they have mentioned multi-port services. We'll see one by one, okay. Yep, I'll take a copy.
Yes.
It is not copied, I think so. Okay, I'll share with this document. Okay, I'll share with you. Yashwant, you have any doubts?
No, sir.
Okay, fine. So tomorrow we'll see about deployments. Okay, these services deployments will use in project. Okay, so I will take a project I will take one application. Okay, so
Okay,
I
sir.
I will we have done in Kubernetes, sorry, Docker Compose, we have deployed one application, right? Mongo Express.
Yesterday,
Sorry.
Mongo Express, that one we have been.
Yes.
That one Mongo Express and
Yes. By using
website,
Docker
yes, sir.
Compose, we have done that, right? So
Yes, sir.
I'll try to use the same application, okay, for Kubernetes. So then it will be easy for you understand.
Okay, sir.
Okay. So like how we have to
Okay, sir.
use deployment, and where we have to use the replicas. Okay, how many replicas we have. So how to use this containers and secrets. Okay, and environment variables we have seen, we
Yes.
have mentioned in that Docker also, right? The same
Yes, sir.
document I'll try to use. I will try to find it from again GitHub, and I'll prepare now.
Yes, sir.
And secrets
Okay, sir.
also, how to generate secret passwords, okay, for that. And express, Mongo Express, pod also, all YAML files, everything. I'll get it and I'll make it ready. So once deployment done, so then after we will discuss about the project, a small project, how application has to deploy on Kubernetes pod. Okay, Kubernetes cluster
Okay,
replica
sir.
set, one second. And these are all over. Replica set. So you might feel little bored because you are learning something new. So that's why, what is this where you are using? Yes, we are creating, and I'm just showing that. I'm just showing how pod is created, and how does it containing, what are the things containing IP address and selectors and all. But if you, this is just a
Yes, sir.
starting steps. That's why you have to understand all these things. Once we are trying to create applications and deploying, while we are deploying on cluster, so then you can understand clearly. Okay, so where we have to use the images and
Okay,
all.
sir.
Okay, so next we'll talk about deployments. So else shall we take a break and start deployments then? What do you say? Your wish.
Okay, sir.
Okay, so then we'll complete the
Okay, sir.
deployments. So then after we'll try to, after completion of deployments, we'll try to set up a small project. Okay, how to deploy in cluster. Okay, so
Yes, sir.
yeah,
But tomorrow I'm not available, sir.
so that's
Because
why
Redance
that's why
and
I'm
have
trying to
informed.
cover deployments also in this class, same class. Okay, so
Okay,
let
sir.
us connect again. So I don't no, don't
Okay,
exit
sir.
from call, just keep in mute. So then
Okay, okay.
just I'll go and come back. I'll need to have some water, and I'll fresh up and come back.
Okay, sir. Sure.
Yeah.
Okay, sir.
Okay, take care. Bye. See you next class.